Okay. What other was we talked about the zero one.
Just the square root one.
The square root. Okay. So in the math packet, it's written like n over, the root of n to a equals a to the power of 1 over n. So that's like kind of what it looks like. If you have the root of n, what it does, it goes on the bottom of our fraction there. So I could show you something like cubed root of x squared. Do you guys know what that would equal? Sorry, can you repeat that?
X squared 1 over, and then like the 1 over 3.
So the cubed root would go on the bottom of my fraction.
And then if the square
And then-
gets canceled.
Yeah, the square goes on the top, like that. So the cubed root of x squared becomes x to the power of 2 over 3. So I could do another one like that. It's right down here. But let's say I have the square root of x to the power of 9. What do you guys think that would equal? Yep, x to the power of 9 over 2. So just remember that whatever's in the root goes on in the denominator of our new exponent. Okay. How's other rules? Okay, well, there's one more thing I want to go over. The expanded power rule. So if I have something like x, y to the power of m, let's say, then my exponent needs to go to both the x and the y. So I'll show you an example, but let's say I had like 2a cubed. So to solve that one, I'd have to cube 2, which is 8. 2 times 2 times 2 is 8. And then I have to cube a, which is a cubed. So that would be my answer to that one. I'll give you guys one to try. Okay, let's do this one. So 6x cubed and all of that squared. Does anyone have an answer?
36x to the 6.
Yep. So I would have to square my 6, which is 36. And then I have to square x cubed. Remember, when there's an exponent to an exponent, we multiply those. So x to the power of 3 times 2 is 6. So that would be my answer. So that was kind of just like a quick review of the powers and exponent rules. And then one thing I want you guys to remember is that to like watch out for parentheses. So if I had -3 squared, that technically equals -3 times -3, which is 9, positive 9. But if someone were to write it like this, -3 squared without a parentheses, we have to follow our order of operations. So what you do first is 3 squared, which equals 9, and then we also have to bring that negative along, so it'd be -9. So depending on whether your answer is positive or negative, depends on if there are parentheses or not. So you'll have to watch out for those because we talk about this all the time, but the ACT does try to like trick you and stuff like that. So make sure to watch out for the parentheses. Okay, so that was all really fast. Just because I thought you guys would know how to do this already. So we're gonna move on to the logarithms. Which are at the top of page 10 in our math packet. We're going to be talking about those. But before we get to any of those properties or anything like that, we're just going to talk about logarithms in general. So, okay, so main thing is that exponential and logarithmic functions are inverses. And so you guys know what inverse means? Yeah? They're kind of like opposite of each other. So exponential and logarithmic functions are kind of like opposites. So I'll kind of show you what that means. But first, I'll show you my exponential function. So let's say I have b, which is my base. That just represents like any number to the power of y. So y is my exponent. That would equal x. So this is kind of like a basic exponential function, and then equals my base, whatever number, to the power of whatever number is going to equal that number. So for my logarithmic function, that would look like log b x equals y. So it kind of looks like that. And then I'll write over here, but my b was the base, y is the exponent, and then x is kind of like our answer. So if I gave you log 3 of 9, to solve that one, remember b is my base, so it's going to be, so these two kind of correlate, but if my base is 3, 3 to the power of x equals 9, because it looks like my logarithm here, so b, y, x, we're kind of transitioning this into this one. So b to the power of y equals x, kind of like an arrow like this. So this would equal 2. And so what happened was 3 to the power of 2 equals 9. So it kind of curves around like that. And so if I were to turn that back into an exponential function, it would just look like 3 squared equals 9. Equals 9. So those two are inverses. Like I said, the exponential and logarithmic functions. Okay, let me erase this. And so kind of what it boils down to is that the answer to a logarithm is an exponent. So we'll do one more example. But I have log base 5, 25. What would that equal? Yep. So if we kind of did our little curve like that, 5 squared equals 25. Okay, so does anyone need this still? No? Okay, so I'm going to give you guys some examples to solve on your own, and then we'll go over. Okay, so I want you to evaluate this logarithm. Okay, does anyone want to call out an answer?
4.
Yep, 4. So what happened was 3 to the power of 4 equals 81. Okay, so let me give you this one. Okay. Yep. So 8 cubed is 512. Okay. And then one more. What do you think this one would equal? Yeah, 1/2. And so how that happened is we want 5 to the power of 1/2. 5 to the power of 1/2 does equal square root of 5 because the same thing as the x, or to the power of 1/2 is the same as the square root. And so that's how we solved that one. Okay, so before we move on, I'm going to show you guys how you can solve these in your calculator, which can save time on the ACT because we always want to save time. So if you have one of these calculators, TI 84 plus, if you turn it on, you're going to press the math button, which is the third one down right under alpha. Press the math button. And then if you scroll all the way down to, it has like an A, and it says log base. So then scroll all the way down to that, press enter. So let's say like I gave you, let's say it was this one. Okay, let's say it was this example again. So where that little subset is, I'm going to type in 8. And then in the parentheses, I'll type in 512, press enter, and then it gives you your answer, which is 3. So you can use your calculator to save time on the ACT if you have something simple like this. It's just like solve the logarithm, and then you'll know your answer is 3. You'll circle it and move on. Okay. So now we've got some properties with logarithms that are also important for saving time and just to know in general. But I have something like log base and my answer is 1. Anything like that is going to equal 0. If I have something where my base and the number in front are the same, so like log b, that equals 1. 2 more. So if I have something like log and then a base and then my b, they're the same, what kind of happens is they cancel out and you're left with just your exponent, which is x. Or it could be any number but x in this example. And then kind of the same thing with this last one, but if I have a number in front, that's the same as my base, and then there's an x out there, that also equals x. So kind of like the same thing, but those two will cancel out. So if you've got those rules written down, we're going to use them to solve our next couple. Does anyone need these still? No? Okay. Okay. So this was one of our properties. But if I had 3 log to the base of 3, do you guys know what this would equal? Oh, sorry, I did not finish writing. Okay, there we go. Had 3 log space of 3, and then 1 there. Do you know what that would equal?
0.
So it's actually going to equal 1. Remember that one rule where if the number out front is the same as the base, it was like cancel out, and whatever's left is our answer. So this would equal 1.
If it was just log 3 to the 1, then it would equal 0.
Mm-hmm. Yeah, but since there's that 3 out there, it equals
Right.
1. Yeah. Okay, I'll actually go up there for this one. Let's see. What if I had this one?
1.7.
Mm-hmm. Yeah, it would just be 4.7. This one over here.
When I put 3 log base of 3 of 1 in my calculator, it says 0.
It says 0.
Yeah.
Did he do the log button, or did he go to the math?
Did you use the log button?
Yeah.
You can't have a base in the log button. Did he go to the math log button? He probably will. It's still
I think okay, so okay, sorry, I figured out the problem, which is literally my bad, sorry. So the 3, sorry for all you guys on screen, and then you'll have to fix this rule in your notes too. But when I said like b log to the b and then the x out front, my logarithm, this part is actually an exponent. So the b is the base down here. So what that one would be was 3 to the power of log base 3 times 1, and so that equals 1. So if you want to type that into your calculator, 3 to the power of log base 3 and then a 1, that should equal 1. Okay, do you guys see that? Sorry about the mistake.
Got it, thank you.
Okay, sorry about that. All right, so let me give you a couple more examples. Say what had this. Sorry, and then one more thing I needed to tell you. So if you see a logarithm with no base, what it means is that there's a base of 10. So you could see something like log 3, and so although they didn't write it there, the base down here is actually 10. And so if you just use the log button in your calculator, that has a base of 10, but if you need to change the base, that's why you need to press math and then go to the actual function. So if I gave you this log 0.001, could you solve this one? and it's actually gonna be negative 3. So what happened is if we do, because the base is 10, if we do 10 to the power of negative 3, we get 1 over 10 cubed, which equals 1 over 1,000, which is the same as my decimal here. Okay. Okay. So now we're going to be talking about natural logs. And so what they are logarithms with a base of e. And so we use ln to denote the natural logs. So if I show you an example, like log to the base of e, the 3 is the same as natural log 3. Okay, so you can use your calculator to solve these two, but let's say, or well, for these you don't need a calculator. But if I gave you ln e power 0.73, you guys know what this would equal? And so what happens is natural log, remember, has a base of e. So technically there's an e down there, and those cancel out. You've just got your 0.73 left. Okay. So this one you can use your calculator to solve, but what about natural log of 4? Do you want to round to the hundredths place?
1.39.
Yep, 1.39. And so I'm sure you guys found it, but there is a natural log button on the calculator. It's right under the log button. It's kind of next to like the 4. You can see it there. But yeah, so natural log 4, you can just type that in and you'll get 1.39 out. Let's see, so this is another one of our properties we're going to use here. But what would the answer to this one be? Yep, it's going to be 6. So we can't forget that my natural log has a base of like e here. So those technically cancel out, and we've just got our 6 left. Okay. And then, you guys want to try solving this one? You can type it into your calculator. Does anyone have an answer? Okay, well your calculator should say error because you can't have a negative log, so that's kind of a trick one. But technically this one is DNE, so it does not exist. You can't have a negative log or natural log. Okay, so we'll be talking about some properties of logarithms. Okay, so kind of like our exponent rules, except they're with logs now. So if I have log base and then x times y, what we can do, and I'm multiplying x and y, what we can do is split that up. that equals the same thing as log, keep the base, x plus log base y. And so similar to our exponent rules, when we are multiplying, that changes into addition. So we've got another rule with division. So if I have log base x over y, that turns into log base x minus log base y. And then one more rule. Have my log base, and then this is to the power of something. There's an exponent here. What we can do is bring that exponent to the front of our logarithm. So it would look like p log base x. So those two are also the same thing. Okay, does anyone still need this? Okay, so we are going to do some practice with expanding logarithms. So if I gave you log 12x 5y to -2, we're going to use the properties that we just learned to expand this one. So technically there are like three, in my logarithm there are three terms here. There's my 12, there's x to the power of 5, and there's y to the power of -2. I'm going to split that up into like three different logs. So how it would look is log 12. Since we are multiplying the 12 and the x to the power of 5, it would be plus log x 5, and then there's one more. We are multiplying here too, so plus log y to the power of -2. And then from there, we're not done yet because we can use that third property we just talked about. When we have exponents, we can actually bring them to the front. So this is going to become, this one will stay the same, it had no exponents. It'll be log 12. I'll do plus 5 log x. And then since that was a -2 I'm bringing forward, I'm going to do -2 log y. So that's how we expand our logarithms. Okay, that makes sense, everyone? Yeah? Alright, I'll give you guys one to try. Okay, so if you can't read it, it says log base 4, 10 t squared u v to the power of -3. And then remember, the base of 4 needs to stay with every single term that you expand. Okay, we'll start going over this one. So if I were to expand this, I'd take out the 10, so log base 4, 10. We're multiplying here, so that becomes plus log base 4 t squared plus log base 4. We gotta keep the 4 u, and then plus log base 4 v to the power of -3. We still got exponents that we can bring to the front, so I'm going to do that in my last step. log 410 plus 2 log 4t plus log base 4 u, and then minus 3 log 4 v. Okay, did everyone see how we got there? Yes? Alright, so we're going to do one with division. I'll have you guys try this one on your own. Remembering the properties that I gave you, so have ln x squared over square root 4x plus 1. Okay, so try to expand this one. Okay, we'll start going over this one. So before I even start explaining, I'm actually going to rewrite this because I don't like the square root. So I'm going to change it to ln x squared over 4x plus 1 to the power of 1/2, because that's the same thing as the square root. And then I'll start my expansion. So natural log x squared. Since we're dividing, that's going to become subtraction, and then natural log 4x plus 1 to the power of 1/2. And then lastly, I'm going to bring my 1/2 to the front of my natural log. So that becomes ln x squared minus 1/2 ln 4x plus 1. Alright, you guys see how we got there?
If there is like a square root or root, do you want us to do that every time?
Yeah, I would do that so that there's like exponent that we can bring to the front, and it's a lot easier to solve. Okay. So I'll give you guys one more example that I want you to solve, and then we'll move on. Okay, so what it says is natural log, so let's go to the whole thing. 3y plus 2 over 4 to the cubed root of y. I want to expand that. Okay, we'll start going over this. I'll change my, so natural log, this top part is just 3y plus 2. Since we're dividing, I'm going to subtract natural log of 4, and then I'm also going to subtract natural log of y to the power of 1/3. And then if I want to go even further, I would bring that 1/3 to the front, but I'm not going to rewrite it. Okay. So now we're going to do the opposite of expansion, which is condensing them. So kind of going backwards. But let's say I gave you this one, so 6. Okay, so 6 natural log x minus 4 plus 3 natural log x. So to start off with, I see that there's a number in front of my natural log, so that tells me it's an exponent. So what I'm gonna like moving backwards. So that becomes natural log x minus 4 to the power of 6. And my second part here is there's a 3 in front, so that also tells me it's an exponent. So plus natural log x to the power of 3. And then lastly, because we're adding here, I know that this is multiplication. So that's just going to become natural log x minus 4 to the power of 6, and then x cubed. Okay, and I guess it's like that time. Do you guys want? Any of you guys want to start your car? No. Okay, so we'll just keep moving on. So this was one example. I'm gonna have you guys try the next one. And I'm gonna have you condense it. So. You know what? It's not this one. Okay, so log 4 plus 3 log x minus 7 log y. Okay, we'll start going over this. So I see there's an addition between my log 4 and then my 3 log x. So that tells me we're multiplying. Front, 4. Oh, and this is an exponent because it's out front, so it's technically x to the power of 3. So 4 times x cubed. And then I see a subtraction, so that tells me we're dividing. There's a 7 out front, so that would be an exponent if it came back over here. So it would be y to the power of 7. Okay, you see how we got there? Yeah. Okay. I'll have you guys try this one. So again, we're going to condense it. Oh, sorry. That's my bad again. There's supposed to be a base of 3 in my first logarithm. Okay, we'll start going over this. So because I have the same base, I can combine them. I notice there's a 4 out here, so that tells me it's an exponent for my x. So I'll start with my log base 3, and then we've got x to the power of 4. I see subtractions, that tells me we're dividing. I already have my log base 3 out here. The 1/3 would be an exponent to my x plus 6. So it would be x plus 6 to the power of 1/3. And then if we remember our powers and exponents rules, an exponent of 1/3 is the same as the cubed root. So that would be my final answer. Okay. Okay. So moving on, last thing. This is also on your math packet, but the change of base formula. So this is a way to like solve if you didn't have a log button on your calculator, I guess you could, or to change the base. What am I trying to say? Okay, so we all have like the log button, but if you didn't have the button that's under math where you can put any base you want, this formula can help you to solve these logarithms. So basically the change of base formula looks like this. So if I have a log base, then x, I would do a log of x, my number out here, divided by the log of whatever my base was. So I'll show you an example. If I have log base 3, 5, what that would equal using my change of base formula is log 5 over log 3. And then remember, when I don't write the base there, it's technically like a base of 10. So instead of going to that math button in your calculator, you can just type, you can just press hit the log button, log 5 divided by log 3. And then you should get 1.46. If you were to use that math button, like press math, go to log base, use a 3 for my base, and then a 5, you would get the same answer. So this change of base formula is just like another way to solve these logarithms. Because the ACT is multiple choice, they can't force you to use the change of base formula, but it could be helpful in some situations. Do you have a question?
Yeah, when we're doing like PEMDAS, is this just the same as exponents in the order part? Logarithms?
Sorry?
In like order, like PEMDAS?
Mm-hmm.
Is this the same as exponents?
Yeah, you do need to use the order of operations always, which is kind of what I was talking about with the negatives and positives.
Are you asking like if it falls under the category of exponents?
Oh, I'm actually not sure on that one. I don't think there'd be like a situation where they'd like overlap with the order of operations and logarithms. But I can find that out for you, and I'll tell you about it next week, okay? I'll figure it out, because I'm not for sure. But yeah, so this is how we use the change of base formula to solve a logarithm. And then I'll have you guys do another one. So even though the ACT like can't force you to use the change of base formula, you can just plug it into your calculator. I'm gonna have you guys try it to solve this next one. So log base the 1/2 6. Okay, so what do you think this would equal? Okay, so if I were to use my change of base formula, it'd be log 6 over log 1/2. And then if I type that into my calculator, you should get negative 2.58. Is that what you guys got? Yeah? Okay. So that was kind of like everything I wanted to go over today. We still have like 10 minutes left. So I'll give you guys some practice problems kind of covering like everything we talked about. Okay. So to solve this one, I'm actually going to change my root into an exponent. So I'll change it to natural log e to the power of 3 over 4. And now that whenever you see like this L and E, just automatically know that they cancel out. Because this technically has a base of E, so that's gone. And then what's left is 3 over 4. So that would be your answer to this one. Alright, one over here. Okay, so log base 5, 1 over 125, if you want to find the value of that. Okay, does anyone want to call an answer?
-3.
Yep, -3. So this is the one where 5 to the power of -3 equals 1 over 25, and that's because with our negative exponents, we move it to the denominator. Okay, I'll have us do one more, and then we'll be done for today.
Sorry.
So I'll have you guys expand this expression. Alright, so it should be, there's 3 terms, x, y, and z squared. So if I expand it, natural log x, we're multiplying, so that becomes a plus. Natural log y, again, multiplication. And then I notice there's an exponent with my z, so I'm actually going to bring that out front. I got 2 natural log z. So that'll be my answer. Okay, we're going to stop there today. So that was kind of an overview of logarithms that you might see on the ACT. And again, like I was saying, they can't really constrict you from using your calculator on some stuff because the answers are multiple choice. They can't tell you to do it like a certain way. Yeah, just use your calculator. So calculators will help a lot. All right. If you guys are on the Zoom, you can head off. Thank you.